All right. Hi, everyone. It's Miss Sabi here. So today I am making a video for my favorite math student in the whole entire world. This is my favorite STEM with Miss Sabi client. Although she never pays me, she has a very large outstanding bill. I'm telling you, like you honestly can't do stuff for people. And it's like, they promise you that they're going to pay you, but they don't. Anyways, back to what I was saying. So, this video is for my favorite client. Wait till you see who it is. It's my baby. It's my baby, Tanea, aka Tizzy. Mommy loves you so much. So, Tanea is in 10 SN. She celebrated her sweet 16, and she was turning up a little bit, but she has a test on the quadratic functions on coming up. And she also has to do this for the mid-year exam and of course the provincial exam. So I created some exercises for her to do and a little package. So I won't go through everything in this video, but just kind of going through some stuff to get her started. So what are quadratic functions? Well, last year in grade 9, you didn't really learn about quadratic functions. You learned about linear functions, right? So linear functions are where the degree, which is the highest exponent on the variable, the degree of the equation was 1, right? So y is equal to 2x plus 6, or y is equal to 1x plus 4. So whenever you plotted those, right? So x and y, independent, dependent variables, whenever you plotted those, they gave you linear graphs. Well, quadratic functions are when your highest degree is a 2. And when you graph that, you get what is called a parabola, right? So it gives you this kind of curve that has an axis of symmetry. It has a vertex, right? And the vertex is where the graph changes direction. So like, for example, this one, it is decreasing. You get to the vertex and then all of a sudden it's increasing. Okay, so now you're looking at quadratic functions, not just linear functions. Um, you started looking at zeros of a function. So if you're like my daughter, they actually started, and all these schools, they started factoring first, right? So finding values of x that make y equal 0. But some schools, like they teach it and they don't really put it into context. So the kids don't know why they're doing it. But when you get to quadratic functions, you realize, oh, I am factoring and I'm finding values of x that make y 0 to find the zeros or the x-intercepts of my parabola, right? So that is why you factor, okay? Sometimes you can't factor, and even like you can't do product sum, you can't do difference of squares and all that stuff. And then you have to use the crazy quadratic formula. And then sometimes you use the quadratic formula and you still can't find zeros. It's not solvable. Why? Because you actually have a parabola that never passes through the x-axis. So it's probably one that opens up. It's in either the first or second quadrant, so it'll never touch here. So that's why you cannot find zeros. So that was that. This is from the Math 3000 book, right? So when you can't use all your cute little product sum and completing squares and all that fun stuff because you don't have things that factor nicely, like product sum, two numbers that when you multiply you get 10 and when you add you get 5 or whatever, and you can't find nice clean numbers, nice integers, well, unfortunately, you have to use this crazy quadratic formula, which is set up for the quadratic function when it's in general form. Okay, so there's that. Okay, so these are just examples of things. So what are the things that you need to know? What should your memory aid have when we're talking about quadratic functions? Well, what you should know is that your vertex, right? it cuts your parabola into two equal parts. So knowing axis of symmetry is very helpful. For example, if you know the vertex and you have 1, 0, right? So where it's passing through the x-axis, then you know that the other 0 is a mirror of the first 0 about the axis of symmetry. So if it's 4 units to the right, that 0, then the other one is 4 units to the left from the vertex. So knowing that there's an axis of symmetry is very important for a lot of problems. Paying attention to the sign of A. So A is that one that is before the x squared. That dictates whether your parabola opens up or down. So if your A is positive, your graph opens up. If your A is negative, you have a parabola that is opening down. Also, if A is negative and it opens down, that means you have an absolute maximum. You have a ceiling on your parabola. If your parabola opens up, it means you have a basement. You have an absolute minimum. Okay, so these things are important, especially for when you are doing the problems in context. So you have three major forms that you look at. You have general form, vertex form, and then you have what is called over here, the factored form or the roots form, okay? So what do we know about the general form? So one thing to keep in mind is that regardless of which form you have, the A is the same thing, okay? If you have another thing in terms of magnitude of the A, if your A is greater than 1, right? So forget about the sign. If your A is greater than 1, then what you have is a skinnier parabola than the general one. It is a skinny parabola because you have a vertical stretch. So the bigger the number, the more stretched it is, the more skinny it is. If you have a number that's less than 1, like a fraction, so let's say 1/2 or something like that, forget about the sign again, you have a compression. So what you have is a chubbier, a wider parabola, okay? So general form, I would organize my memory aid in terms of the different forms because there are different formulas or different things that we can use for different forms. So general form's kind of boring in terms of what it tells you by itself. The only thing it tells you is C is the y-intercept. So wherever your line, your curve goes through the y-axis, that's your C. Not always helpful, but whatever. Sometimes it does come in helpful, but it's not the most informative graph. But you have some formulas. So when you have your general form, so ax squared plus bx plus c, right? So these are your little things that can change. You can use these to find your vertex. So you find your h, right? Which is the x value of your vertex. And you can use that once you take out these values and you know what they are, substitute it into here and find your x value of your vertex. And there is a formula for k, but it's crazy. All I tell my students is, well, when you find the vertex, the h, which is the x value, plug it into your original formula to find out what y is when x is the value of your h. Then you'll find your k, okay? But some kids like formulas, they feel more safe. So that's the formula for the K, but I find students always mess up the math somehow and get the wrong value. So I say find H, use that formula, negative B over 2A, which is easy to remember, and then substitute that value into your original formula. You have this formula, which is the quadratic formula, which is what you used to find zeros before you started studying the quadratic function. This is used to find the zeros when you have the rule in general form, okay? You have the factored form, again, that same A that we see over here in the general form, right? You have the factored form. The factored form gives you the zeros of the graph. So where does this graph pass through the x-axis? In other words, when y is 0, well, that's what this form tells you. And you have the vertex form. So it's called the vertex form, or I think textbooks call it the standard form. It gives you the vertex, right? So A, open brackets, X minus H. So pay attention to the minus sign. And H is the X value of your vertex. K is your Y value of your vertex. This is the vertex form. Obviously, if you have the vertex, then you know the axis of symmetry. So that's helpful. If you want to find the zeros, there is actually a formula to find the zeros when it is in the vertex form. So H, which is the X value of your vertex, plus or minus the square root of negative K, right, over A. Okay, so that is how you find the zeros when it's in vertex form. All right, so just like I said before, even if you have, doesn't matter what form you have, that A remains the same. And it's important to note that. So again, let me repeat myself. So no matter what form you have, the A is the same. So it's important to note that for when you are actually converting between forms, because no matter what, that A is going to stay the same, regardless of what form you are using. So again, this is just me reminding you of all the little things. Your memory aid is what's going to really make or break you for this section. So again, I made these exercises for my daughter. I definitely won't be doing all of these on video because this would end up being like a 6-hour video. So I'm just going to do some of the things. But it's important to be able to identify what form you have so that when you're going to your memory aid, you're knowing what section, you know what section to go in to look for your stuff. So for each function, identify the form. So is it general, vertex, or factored? And determine axis of symmetry. So to determine the axis of symmetry, you need to figure out the vertex, right? Because the axis of symmetry is equal to X is equal to H. So it's a line that goes through the X value of your vertex. So you would need the vertex to figure out your axis of symmetry. Okay. So whichever way, whatever order is makes sense to you. So nuts is not in a particular order. You're supposed to be able to figure out the vertex in any of these forms. So whatever it is you need to do to figure that out, then you gotta do it. Zeros, so if visible or if possible, because not all of your parabolas are going to have zeros. The direction and the A value and its role. So I'm not going to do all that, but let's name all of the different ones. So this, for example, right? This is general form. So this is general, right? If you remember correctly, general is y is equal to 8x squared plus bx plus c. All right, the second one is vertex form. So that's vertex form. The vertex is 4, 7. So remember the general rule of how it's written is x minus h. So if your h is positive, then it remains negative. If your h were negative, then this would have turned into a plus. So your vertex is 4, 7. And let's talk about the parameter a. So here, our parameter a is 2. It is opening up because it's positive, and because it's 2, which is greater than 1, it's going to be skinnier than the basic one. So we have a vertical stretch. Over here, your A is negative, so your parabola is going to be opening down, and it's going to be skinny because it's got a number that's greater than 1, sorry. Over here, what do we have? Well, think about which one has one that looks like this? It looks like a factored form, right? It looks like something you've factored. So you have this 1 that is not visible, but your A is equal to 1. And this is the zeros form. Okay, so zeros or roots forms. And if you remember, that is y is equal to ax minus x1, which is you minus your first root minus your second root. So because this is positive, then this means that 0 is -2, and then this 0 is +6. So what do we have? We have 6, 0 is one of the zeros, and the other 0 is -2, 0. And again, the A is 1, so it's opening up, and it's the same width as the basic standard one. And 4, we have a -1/2. So the A is -1/2, -1/2. And what that means is it's opening down, and because the number is actually less than 1, which is 1/2, it's going to be a wider parabola. And this 2 is in zeros form, right? So this 0, -1, +5. So what are the coordinates of the 0? -1, 0. And the other one is 5, 0. So these are the zeros. Okay, so you could go through and do all this other stuff that's being asked of you. The next thing we're being asked to do is convert between the different forms. Okay, so first, convert to vertex form. So 1. Convert to vertex form by completing the square. So we have y is equal to x squared minus 6x plus 2. So this is what form? So this is general form. Okay, so that is general form. So what we are doing here is we are converting from general form. So we're going from general form to vertex form. Okay, so we are going from general form to vertex form. They specifically said that they want you to use completing the square. On the next page, I will go into detail about completing the square. But for this one, I'm going to also say that you can do this another way. So let's go back up to our little formula section. Okay, so let's remember they're asking us to convert to vertex form. This is the information that we need. So this way, I am going to convert to vertex form using some other formulas, because on the next page, I'm going to talk about completing the square. So in order to convert to vertex form, let's remember what that looks like. That is y is equal to ax minus h squared plus k, where h and k are your vertex. So these are the x and y of your vertex. Okay, so as I mentioned before, your A is the same A that exists in all the forms. So in general form, so there's an imaginary 1 here. So I already know what my A is. My A is equal to 1. So I'm like, all right, I don't need to solve for A, but I do need to know my H and K. So I can use my formula to calculate the H. So let's take out all of the other values, all the other parameters. So my B is equal to -6. So remember, this is your B over here. So this is the A, this is the B, and this is the C. So I'm going to extract all that information. And then the C is equal to 2. Okay, now I'm going to solve for H. So solve for H. So H is equal to -B over 2A. So what is my H? h is equal to, so my b is already negative, right? -6. So there is also a negative sign in the original formula. And then 2 times a, my a is equal to 1. So I have 6 over 2, which is 3. So now I know my h is equal to 3. Now remembering I am trying to convert to vertex form. So let's see what I have so far. I have y is equal to 1, x minus 3 squared, but I do not have my k. So how do I figure out my k? Well, let's... All right, so what I can do is go back now to the original formula. So now, we are going to solve for k. And what that's going to involve is going back to my original formula, which is in general form over here. So I'm just going to copy that. So it's going to involve solving for y. So what we're going to do is solve for y when x equals 3, which is the vertex, right? Because I'm trying to find the vertex. I'm trying to find the k. I already know the h. So then now I'm looking for the value of y when x is equal to 3. So easy peasy lemon squeezy tizzy, you're going to substitute that into here. So here, so I'm going to substitute, and wherever I see x, I'm going to put 3 instead. So I have 3 squared minus 6 times 3 plus 2. Y is equal to 9 minus 18 plus 2. So then we have y is equal to, let's see, so that's 9 minus 18, -9. 2 minus 9 is at -7. So now I know my k. So my k is equal to -7. So I hope I did that math right, but you get the method, right? So now I have everything I need to fit it into vertex form. So y is equal to, remember my a is 1, x minus h, which is 3, and my k is -7. So that is me converting that to vertex form, but that is not in completing the square. So let's try doing this. Let's talk about completing the square. So this is it in vertex form. Again, if I did some of the math wrong, I'm sorry. Doing this quickly, but at least you know the technique, right? So you're going to be doing things on your calculator, making sure that all the math is correct. But remember, this is what we were doing. So I'm just going to put this over here. So like that, like this. So this was general form. And then this is going to vertex form. So this is general, and this is vertex form. Okay, so that was one way of going from general form to vertex form. All right, so let's talk about completing this square. So when you were figuring out all of your factoring techniques, and you had all these things listed on it, one of the special remarkable identities that you were looking at is completing the square. So you were like, oh, if you recognize that it's a perfect square trinomial, you could simply just make the factor of a square of a binomial. So if you realize that it's a perfect square, all you have to do is square root the first term, which here would be x, and use the sign of the middle term, and then square root the third term, which in this case is 9, and then there you go, poof, voila, which is great. So if you identify that, it's a very quick way to factor, okay? But you can still do product sum, but it would obviously take longer. So when you have these little tricks, it's just a way to actually have shortcuts to factor. So that was when you have a perfect square trinomial. When you're completing the square, what you're actually kind of doing is you're forcing the equation into a perfect square trinomial. So you're forcing it that way. Completing the square can be used for two reasons. You can use complete the square to convert something that's in general form, so a quadratic function from general form to vertex form, or you can use completing the square to find the zeros, okay? So we're gonna take a look at what that looks like for both for this function, and we're gonna try to use completing the square for both, okay? So first thing is to remember certain things. How do you identify if you have a perfect square trinomial? So this is going back to when it already is a perfect square. Well, remember A, this is B, this is C. So if your B divided by 2, which in this case is 9, so 9 squared, which is 81, is equal to A, which is 1 here, times C, which is 81, then you have a perfect square trinomial. So this divided by 2 squared is equal to this times this. That is a perfect square trinomial. So now we're going to apply the steps in order to convert a rule that's in general form into vertex form using completing this square. So first thing that we have here, so I have the steps on the side. So move the C to the other side of the equal sign. So what I'm doing here, so I'm moving that C to the other side. So I have Y, and it becomes plus 16 is equal to x squared minus 6x. And I'm going to kind of like leave a little space there. Okay, so it says, move the C to the other side of the equal sign. Don't forget to change the sign. So when you move it over, you change the sign, right? So I know you guys are taught like to get rid of it, I would do plus 16. Hold on, let me just not use that pen. You would have done plus 16, and then what you do to one side, you got to do to the other. But I'm old school. I teach students to move over the equal sign, and when you move it over, then you actually change signs once you go over the equal sign. All right, and so what does it say in the next step? Okay, so the next step says factor out the leading coefficient. So if I had a number here that was other than 1, then I'd have to take it out and factor it out. But in this case, I don't have to do that because I have a 1 there, okay? So that is that step, factor out the leading coefficient. Make what's in the parentheses a perfect square trinomial. So there are supposed to be parentheses because of the fact that you factored out, but remember, we don't really have any factoring out to do because it's 1. So that's why I had put that space over there. So we're going to make this a perfect square trinomial. We're forcing it. So let's remember that relationship. So perfect square trinomials, B divided by 2 squared is equal to A times C. So in this case, because our A is 1, all we have to do is divide the middle term by 2 and then square it, and then we find that. So let's do that on the side, a little side quest. So B over 2 squared is going to give me my C. Remember, because my A is 1. So my B is -6 over 2 squared equals C. So remember, -6 divided by 2, -3 squared is equal to C. So 9 is equal to C. So I am going to put that here. Now I have forced it to be a perfect square trinomial. Okay. Now there's a balancing act going on over here. I just added a 9 over here. I can't just add a 9 on one side and go about my business. It needs to balance out. So if I added 9 to the right side, I need to balance it because now it's like this. Now I need to add 9 to the other side as well. So I'm going to put plus 9 over here. Okay, so 9 and 9. I've balanced it out. Okay, I cannot just randomly add things. Okay, so it says make what's in the parentheses a perfect square trinomial. Don't forget, whatever you add on one side must be added to the other. And then factor what's in the parentheses as a perfect square trinomial, because now it is a perfect square trinomial, right? So what does that look like? So remember the formula for that, okay? So I'm going to just add that 9 and 16. So I have y, let me keep my purple pen. So I have y plus 25 equals, and then I'm going to do what the perfect square trinomial is. So you square root the first term, which in this case is x squared, square root that, which is x. You take the sign of the middle term, which in this case, the sign of the middle term is negative. And then you take the square root of the third term, which is 9, square root that, 3, right? And then I square it. Now that is a perfect square trinomial. Factored, it's a squared binomial. Okay, now you'll notice I have to isolate the y because that's what the vertex form is. Y is equal to a, open brackets, x minus h squared plus k. So I'm going to bring this over. So now I have y is equal to x minus 3 squared minus 25. So now this is vertex form. My h, k are as follows. My h is 3 and my k is -25. So that is me using completing the square to turn this into vertex form. So let's remind ourselves of what we did. We turned y equals x squared minus 6x minus 16 into here, y is equal to x minus 3 squared minus 25. So this went from general form. So again, we are looking at general form to vertex form. So general form to vertex form. Okay, so that is, let me see how long this video is. Okay, this video is 45 minutes. We will call this video converting from general form to vertex form. In the next video, I will start off with looking at how we use completing this square to find the zeros, because then if we find the zeros, then we will be able to convert the general form to the zeros form using completing the squares. So Tizzy baby, I hope that's helpful to you. And, you know, we share the knowledge, we share the wealth. Share it with your friends. I'll share it with my network. Stay tuned. Mom is going to make another video for another section of quadratic functions. This is STEM with Miss Sabi. Tizzy, Mama loves you.